Hello everyone, today we are going through exercise 6.2. First question, show that the function given by f of x is equal to 3x plus 17 is strictly increasing on R. Here given function is f of x is equal to 3x plus 17. It's a polynomial function. And we know that for increasing or decreasing function, the function should be continuous and differentiable. Right? Since it is a polynomial function, it is continuous and differentiable. See, on seeing this function, we can say if it is increasing or decreasing, right? See here, we have a derivative test for increasing and decreasing function. That is, f dash of x is greater than 0, then function is increasing. And if f dash of x is less than 0, then the function is decreasing, right? Here, f dash of x is nothing but, it's very simple function. F dash of x is nothing but 3. 3 is always greater than 0, right? See, on seeing this function, we can say this function is increasing. Strictly increasing, right? Okay, so here we can write, since f of x is polynomial function, it is continuous and differentiable. Continuous and differentiable on R. Okay, so here what is our derivative test for increasing and decreasing function? F dash of x. Our f of x is equal to 3x plus 17. So what is f dash of x? F dash of x is nothing but 3, right? 3. 3 is always greater than 0. So here we have got f dash of x is greater than 0. Therefore, the given function f of x is strictly increasing on R. That's all. Look at the second question. Show that the function given by f of x is equal to e raised to 2x is strictly increasing on R. Given function is f of x is equal to e raised to 2x, an exponential function. And we know that an exponential function is continuous and differentiable. Therefore, this given function f of x is equal to e raised to 2x is continuous and differentiable function. Now let's apply derivative test for increasing and decreasing function. Okay, so for that, first of all, let's write given function f of x is equal to e raised to 2x, then find f dash of x. F dash of x, that is derivative of e raised to 2x with respect to x, that is e raised to 2x into derivative of 2x into 2. Okay, that is 2 into e raised to 2x. So here, is it increasing or decreasing? Means is it negative or positive? Greater than 0 or less than 0? See here, we have to prove this given function is strictly increasing on R. Okay, so on R means set of all real numbers. In set of all real numbers, all the numbers are included, positive values and negative values. Okay, if we substitute any positive values for x, we will get it is greater than 0. Right? We know that. So if you substitute any value, that is for example x is equal to 4, you will get e raised to 2 into 4, e raised to 8. It's always greater than 0. Right? So when we substitute negative values on R, on x, okay, if we substitute negative values for x, so what we will get? See, for example, let's substitute x is equal to minus 2. E raised to 2 into minus 2, that is e raised to minus 4. Is it greater than 0 or less than 0? Here, e raised to minus 4 can be written as 1 by e raised to 4. Right? See, it is obviously greater than 0. E raised to 4 is greater than 0. 1 by positive value, that is positive. Right? It's always greater than 0. So, don't be confused here. E raised to 2x or e raised to any negative values, that is always greater than 0. So, if we substitute any values on R for x, we will get only positive values. 2 is always greater than 0, right? E raised to 2x is always greater than 0 for x. Okay, only for real values, only for real numbers. So, here it is always greater than 0. Okay, therefore, hence f of x is strictly increasing. We have got f dash of x greater than 0. It is strictly increasing on R. Okay, given function is strictly increasing on R. Show that the function given by f of x is equal to sin x is strictly increasing in 0 to pi by 2. Second, strictly decreasing in pi by 2 to pi. And third, neither increasing nor decreasing in 0 to pi. Okay, so first of all, let's go through first one. Okay, given function is f of x is equal to sin x. We know that trigonometric functions are continuous and differentiable. Okay, so here f of x is equal to sin x. Let's find f dash of x. What is f dash of x? Cos x, right? Cos x. So here we have to show it is strictly increasing. Given function is strictly increasing in 0 to pi by 2. Okay. So in 0 to pi by 2, what about cos x? See 0 to pi by 2. Here we know that, see here we have to check whether this cos x is greater than 0 or less than 0 in this interval. Okay. So here 0, pi by 2, pi, 3 pi by 2, okay, 2 pi, okay, etc. So here we know that 0 to pi by 2, in 0 to interval 0 to pi by 2, this interval lies in first quadrant. Okay, it lies since it is in first quadrant. We know that all the trigonometric functions are positive in first quadrant. That is, cos x is positive, right? Cos x is positive in first quadrant. Since 0 to pi by 2 lies in first quadrant, this cos x is always greater than 0 in the interval 0 to pi by 2. Okay, so here cos x is greater than 0. Okay, cos x is greater than 0 in the interval 0 to pi by 2. That is f dash of x is greater than 0 in 0 to pi by 2. Okay, that is f of x is strictly increasing in 0 to pi by 2. Next, what about second one? Here also our f dash of x is cos x. Okay, so in the interval pi by 2 to pi, what is the value of cos x? Means is it increasing or decreasing? Means less than 0 or greater than 0. See here, the interval pi by 2, the values pi by 2 to between pi by 2 and pi lying in second quadrant, right? So here this interval lies in second quadrant. In second quadrant, cos x, our cos x is negative. In second quadrant, sin x and cos x are positive, but cos x is negative. Right? In the interval pi by 2 to pi, this cos x is less than 0. Because in second quadrant, because pi by 2 to pi, the interval pi by values between pi by 2 and pi lies in second quadrant. Okay, that is the interval pi by 2 to pi lies in second quadrant. In second quadrant, cos x is negative. Therefore, cos x is less than 0 in the interval pi by 2 to pi. So here, so we can say cos x is less than 0 in pi by 2 to pi. Therefore, it is f of x is decreasing, okay, strictly decreasing. Because here we will not get less than or equal to 0. Why? Because see, we know that cos pi by 2 is 0, right? But this pi by 2 is not including in this interval because since it is open interval. Okay. If it is closed interval, we can write it is less than or equal to 0. If it is less than or equal to 0, this function is only decreasing. Okay. It is only less than 0. Okay. Here we will not get in the cos of any values between pi by 2 and pi, we will not get 0. Okay. So here f of x is strictly decreasing. In pi by 2 to pi. Okay. Now, see third one. Neither increasing nor decreasing in 0 to pi. See, the interval 0 to pi is nothing but union of this 0 to pi by 2 and pi by 2 to pi, right? 0 to pi by 2, pi by 2 to pi, right? That is nothing but 0 to pi. Okay, the interval is the union of 0 to pi by 2 and pi by 2 to pi. Here we know that, see, that is equal to 0 to pi, right? So here we know that means 0 to pi means, see, it lies in first quadrant and second quadrant. Okay, and here we know that, see, in the 0 to pi by 2, in the interval 0 to pi by 2, the function is, we have already proved, right? So f of x is strictly increasing. That is, in the interval 0 to pi by 2, given function is strictly increasing, and pi by 2 to pi, the given function is strictly decreasing, right? So in the interval 0 to pi, we can say this function is neither increasing nor decreasing. Okay, because 0 to pi is nothing but its union. Okay, that is union of 0 to pi by 2 and pi by 2 to pi. But in this interval, the given function is increasing, and in this interval, the given function is decreasing. Therefore, in this interval, that is in the interval 0 to pi, the given function is neither increasing nor decreasing. Okay, so here we can say the given function here 0 to pi is nothing but 0 to pi by 2 union pi by 2 to pi, right? So here again we can say in the interval 0 to pi by 2, the given function is strictly increasing, and in the interval pi by 2 to pi, the given function is strictly decreasing. Therefore, this function is neither increasing nor decreasing in the interval 0 to pi. Look at the next question. Find the intervals in which the function given by f of x is equal to 2x square minus 3x is, first one strictly increasing, second strictly decreasing. So here we have to find the intervals in which the function is increasing and in which the function is decreasing. Okay. So here we have already studied the method to find the intervals, okay, in which the given function is increasing and decreasing. Okay. So here, first of all, let's write given function f of x is equal to 2x square minus 3x. Then next step is finding f dash of x. Okay, differentiate with respect to x. That is, derivative of 2x square is 4x, 2x, 2 into 2x, 4x minus 3. Okay, so we have got f dash of x is equal to 4x minus 3, and next step is f dash of x is equal to 0. Give f dash of x is equal to 0. Okay, that implies 4x minus 3 is equal to 0. That implies x is equal to 3 by 4. Then we divide the domain into the intervals. Okay, so here x is equal to 3 by 4. Here, since it is a polynomial function, its domain is nothing but set of real numbers r. Okay, that is minus infinity to infinity. Okay, the domain is minus infinity to infinity. So how to divide this domain into open intervals? See here, minus infinity to 3 by 4 and 3 by 4 to infinity. Okay, these are the intervals we have got. Okay, so now next we have to check in this interval the given function is increasing or decreasing. Okay, and in this interval given function is increasing or decreasing. So let's check. Here, first of all, minus infinity to 3 by 4. The given function, okay, here it is our f dash of x, right? See, in this interval, that means all the negative values and positive values less than 3 by 4. Okay, see, what does it mean? The interval, open interval minus infinity to 3 by 4 means the values, all the values minus in between minus infinity and 3 by 4. Right? Here only the positive values less than 3 by 4. See, less than 3 by 4 means less than 1. Okay. Okay. Oh, here, see, let's substitute. Here we have to check whether this negative or positive. Okay, less than 0. That only we have to check, right? Here, less than 0 or greater than 0. See, when we substitute these values, okay, this interval, values in this interval, here for x, what we will get? See, if we substitute x is equal to 3 by 4, See, when we substitute x is equal to 3 by 4, what we will get? 0, right? But here 3 by 4 is not included. Okay, here the only positive values, not only positive values, negative values, all the values less than 3 by 4. Okay, so when we substitute the value less than 3 by 4 for x, what we will get? Okay, suppose 2 by 4. 2 by 4 is included here, right? Because here our interval is minus infinity to, see, minus infinity to 3 by 4, that is the values including less than 3 by 4. Okay, the values are including values the less than 3 by 4. Therefore, here we can substitute only the values less than 3 by 4. Suppose if it is 2 by 4, what we will get? 4 into 2 by 4 minus 3. 4 cancelled. 2 minus 3 is minus 1. So here we have got minus 1. So if you substitute any values less than 3 by 4 for x, we will get negative values, that is less than 0. Okay. So here it is less than, that is minus. Okay. That means f dash of x is less than 0. Okay. So here in this interval we will get f dash of x less than 0. Okay. Next, in the interval 3 by 4 to infinity. Okay, another interval is 3 by 4 to infinity. See here, all the values are positive and the values are greater than 3 by 4. Okay, so when we substitute the values greater than 3 by 4 for x, what we will get? Less than 0 or greater than 0. See, when we substitute the just 3 by 4, it will be 0. Right? So that we have showed here, right? So here, when we substitute all the values greater than 3 by 4 means, so in this interval all the values greater than 3 by 4, right? So when we substitute all the values any values greater than 3 by 4, what we will get? Let's take any example. Okay, see, if you are confusing, you just take any example. See, greater than 3 by 4, just take 5 by 4. Okay, so when x is equal to pi by 4, 4 into 5 by 4 minus 3, that is equal to 4 cancelled, 5 minus 3 is 2. Positive values, right? So if you substitute any values greater than 3 by 4 for x, you will get positive values, that is greater than 0. So here it is positive, f dash of x is greater than 0. So we can say f dash of x is less than 0 in the interval f dash of x is greater than 0 in minus infinity to 3 by 4 and f dash of x is less than 0 in 3 by 4 to infinity. Sorry. It is less than 0, it is greater than 0, right? Okay. So here, in the interval, in minus infinity to 3 by 4, therefore, in the interval minus infinity to 3 by 4, f of x is strictly increasing. Okay, because we will not get 0. Why? Because 3 by 4 is not included. It is an open interval. Okay, 3 by 4 is not included. That is the value is very close to 3 by 4 but less than 3 by 4. Okay, so f of x is strictly increasing. It is because f of x is decreasing. Okay, strictly decreasing. In minus infinity to 3 by 4, f of x is strictly increasing. And in the interval 3 by 4 to infinity, f of x is strictly decreasing. Sorry, increasing. F of x is strictly increasing in the interval 3 by 4 to infinity. That's all. Find the intervals in which the function given by f of x is equal to 2x cube minus 3x square minus 36x plus 7 is strictly increasing, strictly decreasing. So here also we have to find the intervals in which the given function is increasing and decreasing. So for that, first of all, let's write given function f of x is equal to 2x cube minus 3x square minus 36x plus 7. Okay, next step is finding derivative f dash of x. F dash of x is equal to derivative of 2x cube is 6x, 2 into 3x square, so 6x square minus 3 into 2x, 6x minus derivative of 36x is 36, derivative of 7 is 0. Okay, so here 6 is common in these three terms, so let's take it out. 6 into x square minus x minus 6. Okay, now let's make it in the form of x plus a into x plus b. Say it is the polynomial of degree 2. So here we have to make this expression in the form of x plus a into x plus b so that we can find the values of x, that is critical values. Okay, so here how to make? Multiplication is minus 6 and multiplication should be minus 6 and addition should be minus 1. That is multiplication of two numbers should be minus 6 and addition minus 1. So what are the numbers? 3 and 2, right? So here since it is minus 1 plus 1 minus, right? And since it is minus, greater than should be minus. That is minus 3, 2. Okay. So here we can write it as x minus 3 into x plus 2. Right? See, the multiplication is minus 6 and addition is minus 1. So x square minus x minus 6 is x minus 3 into x plus 2. Factorizing. Okay. So here then next step is f dash of x is equal to 0. Finding x values. 6 into, that implies 6 into x minus 3 into x plus 2 is equal to 0. That implies x is equal to, that is x minus 3 into x minus 3 is equal to 0 or x plus 2 is equal to 0. That implies x is equal to 3, x is equal to minus 2. So the critical values are minus 2 and 3. Now let's divide its domain into the intervals, open intervals. Here using these critical values. We know that since it is a polynomial function, our domain is minus infinity to infinity, that is set of all real numbers. Okay, so how to divide this? See here, starting from minus infinity to minus 2. Minus 2 is the smaller value. Okay, so here minus 2, then minus 2 to 3, then 3 to infinity. Okay, so here we have got three intervals. Next, here we have to find in which in these intervals the given function is increasing and decreasing. Okay, in which interval we have to this function is increasing and decreasing. So let's find. It is our f dash of x. Okay, here we have to substitute the values because here we have to find it is less than 0 or greater than 0. So here in the first of all, let's consider the first interval minus infinity to minus 2. Okay, it is our f dash of x. Now here first term is always 0, first term is 6, so 6 is always greater than 0, that is positive. Okay, then what about second? Here minus infinity to minus 2, here all the values between minus infinity to minus 2 are great, all the values are minus and less than minus 2. Okay, here all the values are less than minus 2. So when we substitute any values less than minus 2 for x, what we will get here? See, when we substitute minus 2, minus 5. When we substitute, see, if you are confusing, just substitute any values. Okay, so that is between this interval. Okay, the values should be in this interval. Okay, so minus infinity to minus 2. Here minus 3 is included, right? See, in the interval minus infinity to minus 2, the values are less than minus 2. Minus 1 is not included because it is outside of that, is greater than minus 2. Okay, so here the values, substitute any values less than minus 2 for x. Here substitute x is equal to minus 3. What you will get? Minus 3 minus 3, that is minus 6, that is minus 3 minus 3 minus 6, that is less than 0. So here substitute any minus values, that is x is equal to minus 53. So minus 53 minus 3, that is minus 56, that is also less than 0. So when we substitute any values less than minus 2 for this x, we will get negative only. Okay, that is less than 0. Okay. Then what about second term? See here, in this interval, here we have to substitute x values, that is less than minus 2. So here substitute x is equal to minus 2, you will get 0. Then what about minus 3? You will get minus 1. Then what about minus 4? You will get minus 2. Right? That means when we substitute any values less than minus 2 for this x, we will get minus values only. Right? So here minus. Okay? Because when we substitute minus 2 here, we will get 0. So here we are substituting the values less than minus 2. Right? So obviously it will be minus. Right? So plus into minus, it will be plus. Minus into minus plus. Okay. So f dash of x is greater than 0 in which interval? In this interval, that is minus infinity to minus 2. Next interval is minus 2 to 3. Okay, so first term is positive. Second, minus x minus 3. See, when we substitute, here we have to substitute the values between minus 2 and 3. Okay, so when we substitute minus 2 here, we will get minus 5. Okay, and when we substitute 3 here, we will get 0. Right? So that means it is minus 5, between minus 5 and 0. See, what are the values? Only negative values. Right? So here, if you are confusing, just put any values between minus 2 and 3. It is greater than minus 2, less than 3. Okay? You have to put the values greater than minus 2 and less than 3. Right? That is, if it is minus 2, then 3. The greater than minus 2, less than 3. Okay? So here, for example, minus 1. X is equal to minus 1, you will get minus 4. Right? Or x is equal to 2. 2 minus 3, that is minus 1. Okay? So, or x is equal to 2.5. 2.5 minus 3, that is minus 0.5. So, if we substitute any values between minus 2 and 3 for this x, we will get minus. Okay? So, it is minus. Then what about this one? Here, when we substitute x is equal to minus 2, it will be 0. Then, when we substitute x is equal to 3, it will be 5. Right? So, 0 to 5, all the values are positive. Right? So, when you substitute all the values, any values between minus 2 and 3 for this x, you will get only positive values. Okay? So, it is positive. So, plus into minus, minus, minus into plus, minus. So, it is f dash of x is less than 0 in this interval. Minus 2 to 3. Then, what about last one? 3 to infinity. 3 to infinity. Here, first term is plus, second term. Here, we have to substitute the values between 3 and infinity. That is, greater than 3. All the values greater than 3. All the values positive values. Okay. See, when we substitute x is equal to 3, it is 0. Right? So, when we substitute the values greater than, any values greater than 3, it will be always, obviously it is positive, right? All greater than 0. See, for example, you substitute 23. 23 minus 3, 20. Right? That means here we can substitute the values greater than 3 for this x. So, when we substitute any values greater than 3 for this x, we will get only positive values. Okay? So, it is positive. Then what about this one? Here see, x plus 2, x values are, all x values are positive. That is 3 to infinity, all the values are including between 3 to infinity are positive, right? So, when we substitute any positive value here, it is positive only, right? So, it is positive. Then plus into plus into plus. So, it is plus. So, f dash of x is greater than 0 in this interval. Okay. So, here we have got the given function. Okay. f of x is increasing, okay, strictly increasing. Okay. Here no 0. Okay. Because all intervals are open intervals. Strictly increasing in these two intervals, right? That is minus infinity to minus 2 and 3 to infinity. So that we can write minus infinity to minus 2 union 3 to infinity. Okay, minus infinity to minus 2 union 3 to infinity means all the values are including, that is in the values between minus infinity to minus 2 and 3 to infinity. Okay, so here the given function is strictly increasing in the interval minus infinity to minus 2 union 3 to infinity. Then next, here given function f of x is strictly decreasing in the interval minus 2 to 3. Okay, so only in this interval given function is strictly decreasing. Next question, find the intervals in which the following functions are strictly increasing or decreasing. The first function is x square plus 2x minus 5. Given function is f of x is equal to x square plus 2x minus 5. So we have to find the intervals in which the given function is increasing and decreasing. So here, so first step is find f dash of x, derivative of x, derivative of f of x with respect to x. Derivative of x square is 2x plus derivative of 2x is 2, derivative of minus 5 is 0. Here 2 is common, take it out, 2 into x plus 1. So next step is f dash of x is equal to 0. That implies 2 into x plus 1 is equal to 0. That implies x is equal to minus 1. Okay. So when we take 2 right side, it will be x plus 1 is equal to 0. X plus 1 is equal to 0 implies x is equal to minus 1. So we have got the critical value is minus 1. Okay. Next we have to find the intervals. Okay. Divide the interval. Here interval domain is minus infinity to infinity. Okay. Divide this domain into open intervals using this critical value. That is, intervals are minus infinity to minus 1 and minus 1 to infinity. Okay. Next, here we have to check. It is our f dash of x. Okay. So, in which interval this given function is increasing or decreasing? So, first of all, first interval is minus infinity to minus 1. It is first term, that is 2, that is greater than 0. And what about x plus 1 in this interval? See here, this interval, all the values in this interval are negative, right? And less than minus 1. Okay, all the values are less than minus 1. So here we have to substitute the values less than minus 1 for this x. So here, see, when we substitute minus 1, we will get 0. So what about less than minus 1? Less than 0, right? See, when we substitute x is equal to less than minus 1, it will be 0. Okay, then less than minus 1, it will be less than 0. Okay, because see, if you are confusing, just substitute any values less than minus 1. Less than minus 1 means minus 2, minus 3, minus 4, minus 5. X is equal to minus 5. Minus 5 plus 1, minus 4. Okay, so if you substitute any values less than minus 1 for this x, you will get negative. Okay, this term will be negative. That is minus. So plus into minus, minus, therefore f dash of x is less than 0 in this interval. Okay, then what about minus 1 to infinity? Here all the values greater than minus 1. Okay, so here we have to, when we substitute x is equal to minus 1, it will be 0. Then what about greater than minus 1? Greater than 0, right? See, if you substitute 0, x is equal to 0. 0 is greater than minus 1, right? Okay, so when we substitute x is equal to 0, 0 plus 1 is 1. That is greater than 0. When we substitute x is equal to 10, 10 plus 1, 11. That is greater than 0. So, when we substitute any values greater than minus 1 for this x, we will get only positive values. Okay. So, here first term is always positive. Plus into plus, that is plus. Okay. Plus into plus, plus. So, f dash of x is greater than 0. Since it is plus, plus means greater than 0. Okay. So, here we have got f dash of x is less than 0. F dash of x is less than 0 in this interval. F dash of x is greater than 0 in the interval minus 1 to infinity. So, here we can write f of x is strictly increasing in minus 1 to infinity, and f of x is strictly decreasing in minus infinity to minus 1. That's all. Next given function is 10 minus 6x minus 2x square. F of x is equal to 10 minus 6x minus 2x square. It is given function. Okay, so here first of all let's find f dash of x. Derivative of 10 is 0. Okay, minus 6 into derivative of x is 1. Okay, derivative of minus 2x square is minus 4x. Okay, 2 into 2x, 4x. So here 2 is common. Let's minus 2 is common. Take minus 2 outside. So 3 plus 2x. Right? Okay. So next step is f dash of x is equal to 0. That implies minus 2 into 3 plus 2x is equal to 0. Okay. Now here this implies take minus 2 this side, it will be 0. So how to find the value of x? 3 plus 2x is equal to 0. That implies 2x is equal to minus 3. That implies x is equal to minus 3 by 2. So critical value is minus 3 by 2. Okay. Then, so let's divide the domain into the intervals. So here domain is minus infinity to infinity. It is a polynomial function. Okay. So here the intervals are minus infinity to minus 3 by 2 and minus 3 by 2 to infinity. So let's check in this interval minus infinity to minus 3 by 2. So here, okay, in this interval it is our f dash of x, right? It is our f dash of x. Then, so first term is negative, okay? First term is negative minus. Then here see our interval is minus infinity to minus 3 by 2. That is all the values between minus infinity and minus 3 by 2. That is all the values less than minus 3 by 2. See, when we substitute here minus 3 by 2, what we will get? 3 plus 2 into minus 3 by 2. 2 cancelled. So 3 plus minus 3, that is 3 minus 3, that is 0. Right? So here when we substitute x is equal to minus less than x is equal to minus 2 by 3, we will get this term will be 0. Okay, and so what will happen when we substitute x is equal to less than minus 2 by 3, less than minus 3 by 2. Okay, sorry, less than minus 3 by 2. When we substitute x is equal to minus 3 by 2, it will be 0. So what about less than minus 3 by 2? It will be less than. Right, less than 0, right? So here, for example, here less than minus 3 by 2 is minus 4 by 2. That is less than minus 3 by 2, right? So substitute x is equal to minus 4 by 2. What we will get? 3 plus 2 into minus 4 by 2. 2 cancelled. 3 plus minus 4, that is 3 minus 4, minus 1. So remember here, when we substitute x is equal to minus 3 by 2, this term is 0. So when we substitute any values less than minus 3 by 2 here, it will be less than 0 itself. Okay. So here it is less than. So this term is less than. That is minus. Okay. So minus into minus plus. Therefore f dash of x is greater than 0. Okay. This minus and this term will be minus in this interval. Therefore minus into minus plus. So here f dash of x is greater than 0. And then what about this interval? Minus 3 by 2 to infinity. Here first term is always minus. Okay. Second term, see here also. Here all the values greater than minus 3 by 2. Okay. All the values greater than minus 3 by 2. So here when we substitute x is equal to minus 3 by 2, it will be 0. Right. So what about when we substitute any values greater than minus 3 by 2? It will be greater than 0. Right. See for example, what is the any value? Take any value greater than minus 3 by 2. See, minus 1 by 2 is greater than minus 3 by 2 because minus 1 is greater than minus 3, right? Okay, so here put x is equal to 3 plus 2 into x is equal to minus 1 by 2. Okay, so 2 cancelled. So 3 plus minus 1 is 2. That is greater than 0. So remember here, see, first you have to put what is the interval. Okay, first value. Okay, here minus 3 by 2 is not including. Okay, here the values near to minus 3 by 2 and greater than minus 3 by 2. Okay, so you just check putting x is equal to minus 3 by 2. So if we put this x is equal to minus 3 by 2, this term will be 0. So what about if we substituting any values greater than minus 3 by 2, that will be greater than 0 itself. Okay, so it will be plus. It is minus, it will be plus in this interval. So here plus into minus, minus. So f dash of x is less than 0 in this interval. Therefore, f of x is strictly increasing in minus infinity to minus 3 by 2. Okay, and f of x is strictly decreasing in the interval minus 3 by 2 to infinity. Find the intervals in which the following functions are strictly increasing or decreasing. The given function is minus 2x cube minus 9x square minus 12x plus 1. Given function is f of x is equal to minus 2x cube minus 9x square minus 12x plus 1. So first step is finding derivative f dash of x. F dash of x is equal to derivative of first term, that is minus 2 into 3x square, that is minus 6x square. Okay, minus 9 into 2x minus 18x minus derivative of 12x is 12. Derivative of 1 is 0. Okay, so here 6 is common, so minus 6 is common, let's take it out. Minus 6 into x square, minus taken outside, so okay, so here it will be plus, so plus 3x plus 2, right? Okay, now let's make it in the form of x plus a into x plus b to find the critical values. So here multiplication of two numbers should be 2 and addition is 3. So what are the two values? That is 2 and 1. 2 into 1 is 2 and it is plus value, right? So here no need to be confused. Here 2 into 1 is 2, 2 plus 1 is 3, right? So we can write this as minus 6 into x plus 2, right, into x plus 1. 2 into 1 is 2, 2 plus 1 is 3. Okay. So here we have got f dash of x is equal to minus 6 into x plus 2 into x plus 1. So next step is f dash of x is equal to 0 to find the values of x. So minus 6 into x plus 2 into x plus 1 is equal to 0. That implies, see, when we take this minus 6 right side, it will be x plus 2 into x plus 1 is equal to 0. That implies x plus 2 is equal to 0 or x plus 1 is equal to 0. That implies x is equal to minus 2 and x is equal to minus 1. So these are the critical values, minus 1 and minus 2. So now let's divide the domain into the intervals. Here also domain is minus infinity to infinity because the given function is polynomial function. Okay, so here how to divide? Minus infinity to, starting from minus infinity to, what is the smallest value here? Minus 2, right? So minus infinity to minus 2, okay, and minus 2 to minus 1, then minus 1 to infinity. Okay, so here first interval minus infinity to minus 2. Minus infinity to minus 2. Let's check. It's our f dash of x. Okay, so here first term is always negative. Minus 6. Minus 6 is always negative. Okay, so minus into second term. What about second term? See here, our values between minus infinity and minus 2, that is our values are less than minus 2. Less than minus 2, okay. So here when we substitute x is equal to minus 2, this term is 0. When we substitute x is equal to x is less than minus 2, it will be less than 0, right? When we substitute x is equal to minus 2, it will be 0, okay. So what about when we substitute any values less than minus 2 for this x? It will be less than 0, right? So it is minus. What about this one? See here, x plus 1. Okay, if we substitute minus 2, x is equal to minus 2, it will be minus 1, right? And what about less than minus 2? That is, see, let's take an example. Let's take any values less than minus 2. For example, minus 5. Minus 5 is less than minus 2, right? So, substitute x is equal to minus 5. So, minus 5 plus 1 is minus 4. So, if you substitute any value, that is minus 20. So, minus 20 plus 1 minus 19, right? So, here if we substitute any values less than minus 2 for this x, we will get minus values, okay? That is less than 0. So, minus into minus plus, plus into minus minus. So, total it is minus. So, f dash of x is less than 0. In which interval? In this interval, okay? Then, so here next interval is minus 2 to minus 1. Here the including values are between minus 2 and minus 1. Okay. So it's our f dash of x. So first term is always negative. Okay. Then what about second term? See, here we have to substitute the values between minus 2 and minus 1. That is greater than minus 2, less than minus 1. Right. So when we substitute x is equal to minus 2, it will be 0. Okay. So when we substitute x is equal to minus 1, it will be minus 1 plus 2, that is 1. That is greater than 0. Okay. So let's substitute any values between minus 2 and minus 1. For example, minus 2.5. Okay. Sorry. Minus 1.5. Okay. Minus 2.5 is not included in this interval. Okay. So here the values should be greater than minus 2. So 1.5 minus 1.5 is greater than minus 2. Okay, so let's substitute minus 1.5. What we will get? Minus 1.5 plus 2, that is 0.5. Right? Minus 1.5 plus 2, that is 0.5 plus 0.5. So we will get plus value. Okay. Then, what about this one? See, here also let's substitute minus 1.5. Minus 1.5 plus 1, that is minus 0.5. Right? So here it is minus. Okay. Because here only some values between minus 2 and minus 1. You just take any one value. Okay. And substitute here. And check whether it is negative or positive. Okay. So here we will get, we have got it is minus. Okay. It's always minus. And this one, when we substitute x is equal to minus 0.5, sorry, minus 1.5, that is between minus 2 and minus 1, we have got it is plus. Okay. And when we substitute x is equal to minus 1.5 for this x, we have got minus 0.5. Therefore, it is minus. Okay. So, plus, minus into plus, minus, minus into minus, plus. Okay. So, it is plus, that is f dash of x greater than 0 in this interval. Next interval is minus 1 to infinity. See, here all the values are between minus 1 to infinity. That means all the values greater than minus 1. Greater than minus 1. See, here let's substitute x is equal to minus 1. You will get minus 1 plus 2, that is 1. Okay. And substitute greater than minus 1, right? So, greater than minus 1, take x is equal to 0. What you will get? 0 plus 2, that is 2. That is greater than 0. So, put any values greater than minus 1. Suppose x is equal to 50. 50 plus 2, that is also positive value, right? So, if we substitute any values greater than minus 1 for this x, we will get only positive values. That is, it is always negative, it is positive. Okay. Next, what about third one? See, third one, when x is equal to minus 1, See, when we substitute x is equal to minus 1, it will be 0. But here we have to substitute the values greater than minus 1. It will be greater than 0. Okay. When we substitute x is equal to minus 1, it will be 0. So, when we substitute the value, any values greater than minus 1, it will be positive, greater than 0, right? So, it will be positive. So, minus into plus, minus, minus into plus, minus. So, it is minus. So, f dash of x is less than 0. So, here we can say f of x is increasing, strictly increasing, in which interval? In increasing in this interval, right? Minus 2 to minus 1. Okay. And f of x is strictly decreasing in here minus infinity to minus 2, union or and, you can write and also, okay? Minus infinity to minus 2 and minus 1 to infinity, okay? In these two intervals, given function is strictly decreasing. In minus 2 to minus 1, the given function is strictly increasing, okay? Find the intervals in which the following functions are strictly increasing or decreasing. The given function is 6 minus 9x minus x square. So here given function f of x is equal to 6 minus 9x minus x square. Let's find f dash of x. F dash of x is equal to derivative of 6 is 0, derivative of minus 9x is minus 9, derivative of minus x square is minus 2x. Here minus is common, so minus 1 into 9 plus 2x, okay, that is equal to, okay, so here next step is f dash of x is equal to 0, that implies minus of 9 plus 2x is equal to 0, that implies if we take minus 1 here, it will be 9 plus 2x is equal to 0, 9 plus 2x is equal to 0, that implies 2x is equal to minus 9, that implies x is equal to minus 9 by 2. Okay, so critical value x is equal to minus 9 by 2. Let's divide the domain. So minus infinity to minus 9 by 2 and minus 9 by 2 to infinity. So in this interval, we have to check whether the function is increasing or decreasing. So here minus infinity to minus 9 by 2. It is our f dash of x, okay? It is our f dash of x. So first term, it is minus of, means minus 1 into, right? Minus 1 into. So minus 1 is always negative. So first term is negative. And what about this? 9 plus 2x. See, when we substitute x is equal to minus 9 by 2, 9 plus 2 into minus 9 by 2, 2 cancelled. So 9 minus 9 is 0. So when we substitute x is equal to minus 9 by 2, it is 0. So then what about when we substitute x is equal to less than minus 9 by 2? Less than 0, right? So it will be minus. Therefore totally minus into minus plus. So f dash of x is greater than 0 in this interval. Next is minus 9 by 2 to infinity. Here the values are greater than minus 9 by 2, okay? So here similarly x is equal to, substitute x is equal to minus 9 by 2, it will be 0. So what about when we substitute x is equal to greater than minus 9 by 2? It will be greater than 0, right? So first term is negative, second term is greater than 0, right? That is when we substitute x is equal to minus 9 by 2, it will be 0. So here all the values are greater than minus 9 by 2. So when we substitute any value that is greater than minus 9 by 2, we will get it is greater than 0, okay? That is plus. So minus into plus minus. So f dash of x is less than 0. So here we can write f of x is strictly increasing in minus infinity to minus 9 by 2. Okay. And f of x is strictly decreasing in minus 9 by 2 to infinity. Next function is x plus 1 whole cube x minus 3 whole cube. So here given function f of x is equal to x plus 1 whole cube into x minus 3 whole cube. Okay. So before finding the differentiation, okay, see here, let's simplify this one. Otherwise we have to apply that product rule, so it will be the long expression. Okay. So here f of x is equal to x plus 1. Here a cube into b cube is nothing but a into b whole cube, right? So x plus 1 into x minus 3 whole cube. Okay. That is equal to, let's simplify this one. X square, x plus 1 into x minus 3 is x square minus 2x minus 3 into 1 is minus 3. Right? Whole cube. Okay. So here, next let's find f dash of x. Don't forget to find f dash of x. Okay. So next step is find f dash of x. Here f dash of x, the derivative of x square minus 2x minus 3 whole cube. Derivative of x cube is 3x square. So derivative of this cube is 3 into x square minus 2x minus 3 whole square into derivative of this inside function, that is 2x minus 2. Okay. That is here 3 into x square minus 2x minus 3. See, let's try to write this in the form of x plus a into x plus b. Here it is product of two numbers. Product of two numbers is minus 3 and addition is minus 2. So product of two numbers is minus 3 means minus 2 plus 1. Right? So minus 2 plus 1. Sorry. Minus 3 plus 1. Okay. Minus 3 plus 1. So it will be x minus 3, because addition is minus 2. So larger number will be minus, right? So x minus 3 into x plus 1. Minus 3 into plus 1 minus 3. Minus 3 plus 1 minus 2. Okay. So into here 2 is common. Let's take it out. So it will be 6. 6 into x minus 1. Okay. 2 taken outside. Then so x minus 3 into x plus 1 into x minus 1. So next step, f dash of x is equal to 0 implies 6 into x minus 3 into x plus 1 into x minus 1 is equal to 0. That implies here x is equal to 3. Then when we equate x plus 1 is equal to 0, then it will be x is equal to minus 1. X minus 1 is equal to 0 implies x is equal to 1. Okay. See, that is 6 into x minus 3 into x plus 1 into x minus 1 is equal to 0 implies, see, take this 6 will be here. So it will be x minus 3 into x plus 1 into x minus 1 is equal to 0. That implies x minus 3 is equal to 0 or x plus 1 is equal to 0 or x minus 1 is equal to 0. That implies x is equal to 3, x is equal to minus 1, x is equal to 1. So these are the critical values. Okay. So let's write the domain into the open intervals. Here, what is the smallest value? Minus 1, right? So here, let's write the intervals starting from minus infinity to minus 1. Next, minus 1 to 1. Okay? Minus 1 to 1. Then 1 to 3. 1 to 3. Then 3 to infinity. 3 to infinity. Okay. So we have 4 intervals, right? So let's check whether these intervals, in which intervals given function is increasing or decreasing. See, what is our f dash of x? It is our f dash of x, okay? So here, first of all, minus infinity to minus 1. Here, first term is always positive, okay? Because it is 6. So second, x minus 3 see, it is better to substitute here, because see, if we substitute any, because since square is here, right? Okay, it's a square is there. Okay, sorry, it's a square. Square is there. So x minus 3 whole square, x plus 1 whole square. See, we, even it is a square, we will get the x values only 3 minus 1, 1 itself. Okay, but here, see, when we substitute, it will be very easy, right? See, x minus 3 whole square. See, no need to check. See, when we substitute any values of x, positive or negative, any values of x, here we will get positive only, because since it is a square, right? Negative square is positive, positive square is positive. So no need to check. First, second term is always positive. Then third term is always positive. Okay. Then what about fourth term? Here in this interval, okay. Here in this interval, all the values are less than -1. When we substitute x is equal to -1, it will be -2. So less than -1 means all the values are negative values, right? So negative values, when we substitute any negative values, we will get this one negative only, okay? So minus. So plus into plus, plus, plus into plus, 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 plus into minus, minus. Total it is minus. So f dash of x is less than 0. Okay, in this interval. Then second, -1 to 1. Here, first term is positive. Second term, since it is a square, always positive. Third term is also positive. Fourth term, -1 to 1. When we substitute, see, let's find a number between -1 to 1. See, 0. 0 is included. When we substitute 0 here, we will get 0 minus 1, minus 1. So that is minus value, right? That is less than 0. So it is minus here also. So total it is minus. So f dash of x less than 0. Okay. Then next, in this interval, 1 to 3. First term is always positive. Second term is always positive since it is a square. Third term is always positive. What about fourth term in this interval? 1 to 3. So let's take any number between 1 and 3. That is 2. Okay. 2 minus 1 is 1. 2 minus 1 is 1. That is greater than 0. So if we substitute any values between 1 and 3 for this x, we will get positive value. Okay. So that is positive. So here totally it is positive. F dash of x is greater than 0. Okay. Then next, fourth one, 3 to infinity. Okay. 3 to infinity. Here all the values are greater than 3. So here these three terms are always positive. Plus, plus, plus. So what about the fourth one? 3 to infinity. See, when we substitute x is equal to 3, 3 minus 1, 2, that is greater than 0. So when we substitute all the any values greater than 3, obviously it will be greater than 0, right? That is, see, for example, 10, x is equal to 10. 10 minus 1, 9, greater than 0, right? It is always positive. So, in this interval, okay, 3 to infinity. So, it is plus into plus, all are plus. So, therefore, total it is plus. So, f dash of x greater than 0. Therefore, here we can say f dash of x is strictly increasing in 1 to 3 union 3 to infinity, or 1 to 3, okay, open interval 1 to 3 and 3 to infinity. And sorry, not f dash of x, okay, f of x. F of x is strictly increasing. F of x is strictly decreasing. Strictly decreasing in here. F dash of x less than 0 in these intervals, right? That is minus infinity to minus 1 union minus 1 to 1. Okay. So f of x is strictly increasing in interval 1 to 3 and 3 to infinity. F of x is strictly decreasing in minus infinity to minus 1 and minus 1 to 1. Look at the next question. Show that y is equal to log of 1 plus x minus 2x divided by 2 plus x, x greater than minus 1, is an increasing function of x throughout its domain. That is, here we have to prove this function is increasing function in, what is the domain? X greater than minus 1 means the domain is minus 1 to infinity. X greater than minus 1 means open interval minus 1 to infinity. Okay, so here we have to prove this given function is increasing in the interval minus 1 to infinity. That is, we have to show f dash of x is greater than 0 in this interval. Okay, so first of all, let's write given function y is equal to log of 1 plus x minus 2x divided by 2 plus x. Then next we will find the y dash. If it is f of x, f dash of x, right? Derivative, okay? Derivative of y with respect to x, y dash. So derivative of log 1 plus x is 1 by 1 plus x. Derivative of log x is 1 by x. Derivative of log 1 plus x is 1 by 1 plus x into derivative of 1 plus x, that is 1. Minus, here we have to apply quotient rule. Okay. So denominator into 2 plus x into derivative of 2x is 2 minus numerator into derivative of denominator, that is 1, right? Okay. So divided by square of denominator 2 plus x whole square. That is equal to 1 by 1 plus x minus, let's simplify. Here 2 into 2 4 plus 2x minus 2x cancelled. So 4 divided by 2 plus x whole square. Okay. Next simplify, take cross multiplication. So here 1 plus x into 2 plus x whole square is the LCM. So here we have to multiply 2 plus x whole square. 2 plus x whole square minus 4 into 1 plus x divided by 2 plus x whole square. That is equal to, let's simplify this one, expand. 2 square is 4 plus 4x plus x square. It is in the form of a plus b whole square, that is a square plus b square plus 2ab. So 2 square plus x square plus 2 into x, that is 4x. Minus 4 into 1 minus 4 minus 4 into x minus 4x divided by 2 plus x whole square. That is equal to, here 4 minus 4 cancelled, 4x minus 4x cancelled. So x square, sorry 1 plus x is, okay. So x square divided by 2 plus x whole square into 1 plus x. Okay. So this can be written as x divided by 2 plus x whole square into 1 by 1 plus x. Okay. X by 2 plus x whole square divided by, into 1 by 1 plus x. So that we can easily substitute, right? See, when we substitute any values of x here, since it is a square, it will be positive, right? It will be always positive. So here it is our f dash of x, that means y dash. So here we have to prove this term, that is this f dash of x is greater than 0 in the interval minus 1 to infinity. Okay, see here, this first term in the interval minus 1 to infinity, the first term is always positive, right? This first term is always positive because it is a square. X by 2 plus x whole square. Since it is a square, if we substitute any values for x, it will be positive. Then what about this one? Second term, see when we substitute here, our interval is minus 1 to infinity, right? So when we substitute x is equal to minus 1, it will be 0. It will not be defined because here minus 1 is not included, okay? Minus 1 is not included. So greater than minus 1. So here we have to substitute the values of x greater than minus 1. Okay, that is put x is equal to minus 0. Okay, greater than minus 1 means 0, 1, 2, 3. Okay, etc. So put x is equal to 0, you will get 1, that is greater than 0. Put x is equal to 3, you will get 4. 3 plus 1, 4. So 1 by 4 is always greater than 0. 4 is greater than 0, then 1 by 4 is also greater than 0. So here you will get this term is also greater than 0 in this interval. So second term is also greater than 0. Therefore totally it is plus, then f dash of x is greater than 0. Okay. So you can write f dash of x is greater than 0 in the interval minus 1 to infinity. Okay. Or you can see one more step, you can add f of x is always f dash of x. In f dash of x, the first term x by 2 plus x whole square is always greater than 0 and 1 by 1 plus is also greater than 0 in the interval minus 1 to infinity. Therefore, f dash of x is greater than 0. It is plus, right? It's greater than 0 and this term is also greater than 0. So, plus into plus, plus, right? So, f dash of x is greater than 0 in the interval minus 1 to infinity. That is, f of x is increasing in minus 1 to infinity, or x greater than minus 1, or we can say the given function is increasing function when x greater than minus 1. Okay, f of x is increasing function, is an increasing function when x greater than minus 1. Okay. Find the values of x for which y is equal to x into x minus 2 whole square is an increasing function. Okay. So that means, see here we have to find the intervals. Okay, values means find the values of x means we have to find the intervals in which the given function is an increasing function. Okay, so let's write. Okay, given function y is equal to x into x minus 2 whole square, right? So we need to find the derivative, right? So let's simplify. Here let's take x here. So it will be x square minus 2x whole square, right? Okay, next we will find derivative y dash, that is 2 into x square minus 2x into derivative of this inside function, that is 2x minus 2. Okay, that is equal to, here 2 is common, let's take it out, and here x is common, so take x outside. So 2 into x, so 4x. So 4x into here x minus, x taken outside from this, so x minus 2, right? X minus 2 into here 2 is taken outside, so x minus 1. So we have got y dash is equal to 4x into x minus 2 into x minus 1. So when y dash is equal to 0 implies 4x into x minus 2 into x minus 1 is equal to 0. It is the method to find the intervals. Okay. So here this implies x is equal to 0. 4x is equal to 0 implies x is equal to 0. X is equal to 0. X is equal to 2. X minus 2 is equal to 0 implies x is equal to 2. X minus 1 is equal to 0 implies x is equal to 1. So these are the critical values. Okay. So let's divide the interval. Minus infinity to smallest value is 0. So minus infinity to 0, 0 to 1, 0 to 1, then 1 to 2, 1 to 2, then 2 to infinity. Okay, we divide the minus infinity to infinity. Okay, we divide the domain minus infinity to infinity into the intervals, open intervals. Minus infinity to 0, we have to take the smallest number among these. Okay, that is 0. Then 0 to 1, next number is 1. So next 1 to 2, then 2 to infinity. Okay. So now let's check in which intervals the given function is increasing. Okay. So we have to check all the intervals. Minus infinity to 0. Okay. Which is our y dash? Y dash. This is y dash. Okay. So here, so first term 4x. So x is here. Right. See. In the interval minus infinity to 0, all the values are negative, right? See, here the values, all the values are less than 0 means all the values are negative, right? So here when we substitute any negative values, it will be negative, right? 4 into negative values, that is negative, okay. So minus. So here, next, when we substitute any negative values, here it will be negative only, that is, see, minus 1, minus 2, minus 3, minus 2, minus 2, minus 4. So, all the values are negative. So, here also when we substitute any negative values in for this x, so here also we will get less than 0, that is negative. Okay, 3 terms, right? Okay. So, minus into minus plus, plus into minus, minus. Total it is minus. So, here not f dash of x, y dash. Okay, y dash less than 0. Next, Next interval is 0 to 1. 0 to 1. Here 0 to 1 means all the values are positive, right? So all the values are between 0 to 1 are positive. Okay. So here when we substitute any positive values, x here positive. Okay. So it is always positive. Then x minus 2. Here see when we substitute any values less than 1 means values between 0 and 1, what will be here? See, let's check. Let's substitute x is equal to 0.5. Okay. 0.5 is between 0 and 1, right? So 0.5, what we will get? 0.5 minus 2, that is minus, right? Minus 1.5. So it will be minus. So here it is minus. Next, what about this one? Here also, see, when we substitute x is equal to 1, it will be 0. So when we substitute x is equal to less than 1, it will be minus, right? See, put x is equal to 0.5. Okay, in this interval, 0.5 is included. So 0.5. 0.5 minus 1 is minus 0.5, right? So it will be minus. So plus into minus, minus, minus into minus, plus. So here y dash is greater than 0. Y dash is greater than 0. Next interval 1 to 2. Let's check here. 1 to 2. Here always positive, right? 1 to 2 means all the values are between 1 to 2 are positive values, right? So when we substitute it here, it is positive. So first one is positive. So next, here 1 to 2. See, 2 is the last number, right? So when we substitute, 2 is not included here, okay? So that is closest to the values very close to 2 but less than 2. So here when we substitute x is equal to 2, it will be 0. So what about when we substitute any values less than 2, it will be minus, right? Less than 0. So here, for example, 1 to 2 means 1.5 is included, right? So 1.5 minus 2, that is minus 0.5. So it is minus. And here when we substitute, our interval is 1 to 2. So substitute x is equal to 1. When we substitute x is equal to 1, it will be 0. Then what about when we substitute x is greater than 1? Greater than 0, right? So it is positive. So plus into minus, minus, minus into plus, minus. So it here y dash less than 0. Then next interval 2 to infinity. 2 to infinity. Okay, here 2 to infinity, all the values are positive in this interval, right? That is, all the values between 2 to infinity are positive. So here surely it is positive. Okay, so first term is positive. Next, what about this one? Our interval is 2 to infinity, right? That means all the values are greater than 2. Okay, so when we substitute x is equal to 2, it will be 0. Then when we substitute values greater than 2, it will be greater than 0. Okay, so it is positive. Then next term, here x minus 1. So here also see our interval, that is starting from 2. Okay, so when we substitute x is equal to 2, 2 minus 1, that is 1, that is greater than 0. So when we substitute the values greater than 2, it will be greater than 0, right? Obviously it is greater than 0. See, if you are confusing, just substitute any values between these intervals, okay? These values, that is 2 and infinity. Any values, all values are positive, right? So substitute x is equal to 3. 3 minus 1 is 2. So it is positive. It is greater than 0. Okay. So plus, all are plus, therefore total it is plus. So y dash is greater than 0. So here we have to find the values of x for which the given function is an increasing function. Okay. So here we have found y dash is greater than 0 in which interval? 0 to 1 and 2 to infinity, right? Y dash greater than 0 in 0 to 1 and 2 to infinity. So we can write the given function y is increasing is an increasing function when here we can write 0 less than x less than 1 and 2 less than x less than infinity, or 0 to infinity. Okay, or we can write x greater than 2. Okay, x greater than 2. Prove that y is equal to 4 sin theta divided by 2 plus cos theta minus theta is an increasing function of theta in closed interval 0 to pi by 2. Okay. So here we have to prove given function is an increasing function in the interval 0 to pi by 2, closed interval 0 to pi by 2. Okay, so for that, so first of all let's write y is equal to 4 sin theta divided by 2 plus cos theta minus theta. Then next find the derivative, that is y dash with respect to theta, okay, dy by d theta. So here first term, derivative of first term, apply quotient rule, 2 plus cos theta into derivative of 4 cos theta is minus 4 sin theta is 4 cos theta, so 4 into cos theta minus 4 sin theta into derivative of 2 plus cos theta, that is minus sin theta, divided by square of denominator, that is 2 plus cos theta whole square, and minus derivative of theta with respect to theta is nothing but 1, right? Derivative of x with respect to x is 1, right? Similarly, derivative of theta with respect to theta is 1. Now let's simplify. Here 4 into, okay, 4 into 2 cos theta, okay, 2 into cos theta, 2 cos theta, plus cos theta into cos theta, cos square theta. Here minus into minus plus 4 sin square theta divided by 2 plus cos theta whole square minus 1. That is equal to, see here, when we multiply these terms by 4, it will be 4 cos square theta, right? Okay, let's write 8 cos theta plus 4 cos square theta plus 4 sin square theta divided by 2 plus cos theta whole square minus 1. Okay. Then here see 4 cos square theta plus 4 sin square theta. See in these two terms, let's take outside 4. Let's take 4 outside. So it will be 4 into sin square theta plus cos square theta. Sin square theta plus cos square theta is 1. So it will be 4 into 1, 4. Okay. So these terms become 4. That is equal to 8 cos theta plus 4 divided by 2 plus cos theta whole square minus 1. Now let's take LCM. So it will be 8 cos theta plus 4 minus 2 plus cos theta whole square divided by 2 plus cos theta whole square. Again simplify here. So 8 cos theta plus 4 minus 2 square is 4, okay, minus 4. Then here 2 into 2 cos theta, that is minus 4 cos theta, plus cos, it is in the form of a plus b whole square, right? So a plus b whole square, and I have multiplied this minus also, okay? So minus 4 cos theta plus cos square theta, so minus into plus cos square theta minus cos square theta divided by 2 plus cos theta whole square. Okay. So here plus 4 minus 4 cancelled. Then 8 cos theta minus 4 cos theta, that is plus 4 cos theta, right? 4 cos theta. 8 minus 4, 4. 4 cos theta minus cos square theta divided by 2 plus cos theta whole square. Y dash is equal to. Okay. So that is equal to, here cos theta is common. So cos theta, take cos theta outside. So 4 minus cos theta divided by 2 plus cos theta whole square. Enough. Now we can, we have to find y dash greater than 0 or less than 0. Okay, we have to prove it is greater than 0. Okay. So in the interval 0 to pi by 2, in the interval 0 to pi by 2, what about this one? Cos theta, always positive, right? That is See, in the interval 0 to pi by 2 means 0 to pi by 2, it lies in first quadrant. In first quadrant, cos theta is positive. Okay. Therefore, in the interval 0 to pi by 2, cos theta is greater than 0. See, what about this? This one no need to check since it is square. Okay. 2 plus cos theta whole square. If it is minus also, it will be square. Right. Oh, so here no need to check. Then what about this one? In interval 0 to pi by 2, here it is always greater than 0. Why? Because we know that the range of cosine function is minus 1 to 1. That is, value of cos function is only between minus 1 and 1. That is minus 1 to 1. Okay. So this one always will be less than 4. Okay. If it is greater than 4, it will be minus. Right. If it is, suppose cos theta is equal to 5. So 4 minus 5, it will be minus. Right. But here cos theta values are between minus 1 to 1. Okay. Between minus 1 and 1. Okay. Therefore, it is always less than 4. Okay. Therefore, 4 minus cos theta is greater than 0. Okay. It is positive. And it is also positive. Therefore, all terms are positive. Hence, this function y is or y dash is greater than 0 in interval 0 to pi by 2. Okay. But what about this closed interval? See, y dash is always greater than or equal to 0 in the closed interval 0 to pi by 2. Why? Because we know that cos pi by 2. Here, closed interval 0 to pi by 2 means pi by 2 is included, right? 0 is also included, pi by 2 is also included. What is cos pi by 2? 0, right? So, our y dash is greater than or equal to 0. Greater than or equal to 0 because pi by 2 is included and cos pi by 2 is 0. Okay. Therefore, in the closed interval 0 to pi by 2, y dash is greater than or equal to 0. Hence, the given function y is an increasing function, not strictly increasing. It is strictly increasing in upper interval 0 to pi by 2 and increasing in closed interval 0 to pi by 2. Okay. Hence, y is an increasing function in closed interval 0 to pi by 2. Okay. And we can say the given function is strictly increasing in upper interval 0 to pi by 2, but it is an increasing function in closed interval 0 to pi by 2. Prove that logarithmic function is strictly increasing in 0 to infinity. Simple one. Okay. Given function is logarithmic function, that is log x. Okay. So f of x is equal to log x. So we have to prove this function is increasing function in the interval 0 to infinity. Okay. So here, first of all, let's find f dash of x. F dash of x is nothing but 1 by x. Okay. So in 0 to infinity, see all the values in 0 to infinity are positive. Right. All the values in 0 to infinity are positive, that is greater than 0, right? So here when we substitute any values, positive values for x, it will be positive, that is 1 by x is also positive, right? So in the interval 0 to infinity, 1 by x is always greater than 0. Greater than 0, not greater than or equal to 0 because 0 is not included. Or if 0, x is equal to 0, it will not be defined. Okay. So here 1 by x is always greater than 0 in the interval 0 to infinity. Okay. Because all values are positive values. Okay. So here directly we can write f dash of x. Therefore f dash of x is greater than 0 when x belongs to 0 to infinity, okay, or you can write in the interval 0 to infinity. Hence, f of x is equal to log x or logarithmic function is strictly increasing in 0 to infinity. That's all. Okay, because 1 by x is the f dash of x is 1 by x, and when we substitute any positive values in x, it will be positive. So 1 by x is also 1 by positive value is also positive value, right? Therefore 1 by x is greater than 0 in the interval 0 to infinity. Okay, that is f dash of x is greater than 0. If f dash of x is greater than 0, then given function is f of x is strictly increasing in the interval 0 to infinity. Prove that the function f given by f of x is equal to x square minus x plus 1 is neither strictly increasing nor strictly decreasing on minus 1 to 1. So here we have to prove the given function is neither increasing nor decreasing on the interval minus 1 to 1. So here also we will apply the same method to find the intervals. Okay. So given function is f of x is equal to x square minus x plus 1. Then next step is find derivative f dash of x is equal to 2x minus 1. Okay, then f dash of x is equal to 0. Same method to find the values of x. Okay, here 2x minus 1 is equal to 0 implies x is equal to 2x is equal to 1, that implies x is equal to 1 by 2. Okay, so let's divide the interval into two open intervals, that is minus 1 to 1 by 2 and 1 by 2 to 1. Okay, minus 1 to 1 by 2 and 1 by 2 to 1. So first of all, let's check in which intervals the given function is increasing or decreasing. Okay, so minus 1 to 1 by 2, the function f dash of x, our f dash of x is this one, 2x minus 1. See here, when we substitute x is equal to 1 by 2, here it will be 0, right? And here in this interval, all the values are less than 1 by 2, right? In this interval, all the values less than 1 by 2. When we substitute x is equal to 1 by 2, 2 into 1 by 2 minus 1, 2 cancel, 1 minus 1, 0, right? So here, when we substitute x is equal to 1 by 2, it will be 0. Then what about when we substitute x is equal to less than 1 by 2? Less than 0, right? That means f dash of x less than 0. In the interval minus 1 to 1 by 2, f dash of x is less than 0. And what about 1 by 2 to 1? Okay, so here f dash of x, here all the values greater than 1 by 2. Similarly, we can substitute x is equal to 1 by 2, it will be 0. Okay, when x is equal to 1 by 2, it will be 0, f dash of x is 0. But when we substitute x is equal to greater than 1 by 2, it will be greater than 0, right? So it will be greater than 0, that is f dash of x is greater than 0. So here we showed that f dash of x is less than 0 in the interval minus 1 by 2, 1 by 2, minus 1 to 1 by 2. That means given function f of x is strictly decreasing in the interval minus 1 to 1 by 2. Okay, f of x is strictly decreasing in minus 1 to 1 by 2, and f of x is strictly increasing in 1 by 2 to 1. Okay, because f dash of x is greater than 0 in the interval 1 by 2 to 1. Therefore here see, my interval minus 1 to 1 is divided into two intervals, that is minus 1 to 1 by 2 and 1 by 2 to 1. Okay, that is minus 1 to 1 is divided into two intervals, minus 1 to 1 and 1 by 2 to 1. Okay, therefore in minus 1 to 1 by 2, this given function is strictly decreasing, and in the interval 1 by 2 to 1, given function is strictly increasing. Then in the interval minus 1 to 1, the function is decreasing and increasing. Therefore we can say in the interval minus 1 to 1, the function is neither increasing nor decreasing. Okay, therefore f of x is neither increasing nor decreasing in minus 1 to 1. Okay, in the interval minus 1 to 1.